In this video, I will attempt to outline a theory of the working principles of an astronautical drive system and how thrusters work to power a vehicle, vessel, or craft. First, what is an astronautical drive? In short, an astronautical drive is the prime mover of any astronautical vehicle, vessel, or craft. Second, what is an astronautical drive system? In short, the astronautical drive system is all the necessary components and systems engineered for the operations of the drive system. In the context of an astronautical drive, what is a thruster, and how does it work? In the context of an astronautical drive system, a thruster is an auxiliary power source whose primary function is to provide power to yaw, pitch, and roll systems with minimum to no destructive environmental impact. Thrusters are the primary drive system utilized for maneuvering. While it is possible for thrusters to be fuel and power independently as part of the astronautical drive system, thrusters are typically powered by a waste exhaust of hazard drive systems. Part 2. Pistons, turbines, and rocket Newtonian mass reaction drive thrusters. Pistons, turbines, and rockets all work based on the principles of thermodynamic equilibrium and displacement, governed by the laws of thermodynamics and Newtonian laws of motion. The fan and the propeller both perform the same function. They generate thrust. What differs between them is that a fan is not an airfoil and generates thrust through direct fluid displacement. A propeller, on the other hand, is an airfoil. When made wings to produce lift could also be used to generate thrust. The principles of Newtonian mechanics apply to both fans and propellers. Turbines and rockets, on the other hand, while they also obey Newtonian mechanics, their form and functions are governed more by thermodynamics. Whereas open fans and propellers can be considered as open thermodynamic systems, turbines and rockets are better understood as isolated and closed thermodynamic systems. Jets and rockets are better understood as isolated and closed thermodynamic systems. Rockets being isolated and closed thermodynamic systems, and turbines being predominantly considered as thermodynamically closed systems. Fans and propellers can be driven by many different types of motors, engines, or drives. They are prime movers consisting of rotating blades. When the blades are airfoils, they are propellers, and when the blades are non-airfoils, they are fans. Typically, fans and propellers are open blades and can be said to be open thermodynamic systems. They are also separate and isolated from their power plant, which is a motor, engine, or drive. The power plant or prime mover, which drives fans and propellers, are isolated and closed systems. Turbines have 6 components comprised of complex systems. 0. Bypass fan. 0 is the bypass fan. The bypass prop is connected to the compressor and powered by the turbine. The bypass fan generates a large volume of slower, cooler air, which flows around the turbine engine, helping to keep the main parts of the engine cool. 1. Compressor. First is the compressor. The compressor typically consists of blades, usually fans. The job of these blades is to both draw air inward as well as to compress the air and force the air into the combustor. 2. Combustor. Second is the combustor. The combustor mixes some of the air with fuel, then ignites it, causing the mixture to expand rapidly and move much faster. This increase in speed and pressure is used to power the turbine. 3. Turbine. Third is the turbine. Like the compressor, the turbine consists of blades. As the high pressure and high speed air escaping the combustor moves through the turbine, some of the energy from the air is exchanged with the turbine. As a result, the turbine rotates or spins. As the turbine is connected directly to the compressor also spins more rapidly. Controlling the exhausted air coming from the combustor regulates directly the turbine and indirectly the compressor. 4. Reigniter. Fourth is the reigniter, also referred to as the afterburner. Once the hot exhaust gas leaves the turbine, traditionally they exit the turbine engine through the exhaust nozzle. However, some turbine engines take advantage of the principles which power a rocket engine and add a second combustor after the turbine, where more fuel can be added to the hot exhaust gas. The remaining oxygen is fully burned and the energy generated is utilized for further power of the craft. 5th, exhaust nozzle. 5th and lastly, the exhaust nozzle. This is the exit port of the turbine engine, where the high temperature, high pressure exhaust can exit the craft and propel the craft forward. All of the hot exhaust which comes out of the exhaust nozzle. Rockets have 5 components comprised of complex systems. Rockets in context of this body of work have 5 components comprised of complex systems. A rocket should be thought of in context as an isolated or closed turbine engine. Instead of drawing oxygen out of the atmosphere, rockets carry an oxidizer as fuel. Because of this, a compressor open to the atmosphere is not necessary. Rockets are designed to operate in the vacuum of space outside and beyond planetary atmosphere, which makes an aerodynamic compressor obsolete. By carrying an oxidizer on board as part of its payload, rockets can operate in an environment until they exhaust their fuel and oxidizer supply. Liquid fuel and liquid oxygen tank. First is the fuel and oxygen tanks. This is where the propellant is stored, typically in a liquid fuel rocket. 2. Turbine pump. The turbine pump draws a small amount of both fuel and oxygen out of their tanks to power the rocket engine. 3. The rocket combustor. The rocket combustor is where the fuel and oxygen mixture is combined, then ignited. 5th, rocket exhaust nozzle. The rocket exhaust nozzle is where the hot rocket gas exhaust escapes the craft, propelling the rocket forward.